All right, so 5.4b, even answers. They're written kind of weird, but you should be able to find them all. Pause the video and check your evens, and then we'll come back with questions. This says factor completely, and I've drawn this picture a bunch of times, greatest common factor. Then you either have 2, 3, or 4. This is a 4. 4 is always factor by grouping if we're trying to factor, okay? So just a rule. At the end of this problem, we're not trying to solve for it because it's not an equation, okay? So we can't say equals any answers. We're just trying to factor it. So factor by grouping always has 2 steps. The first step is to look at it in pairs. And if there's a minus right here, we're going to take it out. We're going to use it in our factoring. So there it is, that minus. What's common in my first pair? What do the two things have in common that I can take out? C. And how many C's can we take out? 2. C squared and the 4. Okay, so that's what we're taking out. Greatest common factor. That's the part of the 2 steps. That's what happens in those 2 steps. Greatest common factor. So we took out almost everything here, but there's a C left. And then we have a plus sign. And then 2. And we took out all the C's. So that's done. That's everything for that. So first pair is done. Second pair, we're going to take out this minus and then look at the numbers again. So how about these numbers? What's the most numbers? Again? 9, thank you. And then this one doesn't have a C, so we're not taking C's out this time, just the 9. So what's left is negative 9 times C makes 9C. And then negative times another negative, and then a 2 will make, oopsies, positive. Okay, so think through it. Because I was going to put a minus there, and that would have been wrong, because negative times positive makes negative. I needed it to be positive because now I have the same things. So right here, this is 4 terms. 1, 2, 3, 4, separated by pluses and minuses. This one is only 2 terms, because there's only one minus sign here. And in these 2 terms, this is the second step, I'm looking for the greatest common factor again. This is a factor, this is a factor, and this is a factor. 9 is a factor, and C plus 2 is a factor. We're taking out this whole factor, C plus 2, out of both of them. And when I take it out, I'm going to have 2 things left in parentheses. So, in this first one, I take this out, and 4C squared is left. I keep the sign, minus. When I factor this one, I take out the C plus 2, and I have a 9. So I don't take out a C plus 2 twice. It doesn't say squared here. And students tend to do that sometimes. That's a common mistake. But we don't do that. Because like here, this 9, I didn't say 9 squared is 81. I only took out one 9 from both of these. Does that make sense? This just looks funny because it's a binomial. If you cross it out, it will help you not do that mistake. When you factor, to factor completely, you look at it and go, is everything in the first degree? Do I have the first degree for everything? This C plus 2 is the smallest it can be. But this one is C squared, so maybe it will factor. Go over here. They don't have anything in common. 4 and 9 are not common. Neither of them have, or both of them don't have a C. That's not it. But it is a binomial, which means if it factors, it has to be something special. Are 4, C squared, and 9 special? Danny. Oh, you do the best you can with your eyeball. So 4 is a square. C is squared because it says C squared, and 9 is a square. They're special. Is it special enough to be one of my specials? What will we call this? Is it a sum or a difference? Difference of squares. That is special. So my specials are either difference of squares or difference of cubes or sum of cubes. Those are the 3 specials that we have to memorize. This one is a special because it's a difference, and these are all squares. So we're going to keep the C plus 2. Then we're going to make this into the unspecial part. We're going to factor it, and we're taking square roots, so it'll be 2C and 2C, 3 and 3, and 2 different signs. Okay. So now it's factored all the way. There's nothing, I can't go any lower than the first degree. I can't make it 0 degree. Then it would disappear. So they all have first degree. I'm definitely done now for 23. Is that better? So it had two different things in it, factor by grouping and a special. Next on my list is 25. 25 says a to the fourth, and these are completely the same and completely different at the same time. So this one, 25, looks like a trinomial. So trinomial goes into two sets of parentheses. That's the rule for when there's three terms. 1, 2, 3. But this is x. This is not x. It's a to the fourth. So there's a rule here that says if we know it's going to be two sets of parentheses, the rule says I'm going to think about it like a regular factoring problem, but I'm not going to put a and a. Instead, I put a and divide this by 2. So it's a squared and a squared. Okay, so that's a rule that we just have to learn to recognize. But first, if you see it's a trinomial, you're going to think two pairs of parentheses. And then the second part is, okay, it's not a to the fourth. I could multiply all kind of things, right? Like a to the third times a to the first, that's a to the fourth. But that doesn't help me because this is a squared. So you can either think of it as dividing this one by 2, or you can think of it as the same as the middle term. Because when I multiply this out, what are factors of 6 that add up to 7? 1 and 6. And they're both the same sign. So when you check it, it would be a squared times a squared is a to the fourth. This on the outside is a squared. This is 6a squared, and this is 6. This makes 7a squared. It has to be that these are the same as the middle one so that they'll add up and be that same degree, okay? So for these special ones that have a higher one, you can actually look at that middle term. If they're written in the right order, big and then little and then no degree, you can use that. So 25 was something you had to memorize. 33 was, nope, I lied. 27 is next on my list. 27. So this is in the same group. 32, z to the fifth minus 2z. So, always first is greatest common factor. 32 and 2, do they have anything in common? 2, we'll take that out. Any z's? Just the one z. And this is why I crossed mine, because mine look the same. What's left is 2 goes into 32 16 times. I took 1 out, so that leaves 4. And I took everything out here, so I leave 1 as a placeholder. I like that placeholder word, because when I take out stuff, I have to have this many terms when I take out greatest common factor. So what I'm left with, I'm thinking about here, this is to the fourth. It's not the smallest it could be. I go up here and go, well, it's a binomial. It has to be special. It is a difference, and 16 is a square. It's probably difference of squares. So I'm going to factor it. In this idea of factoring difference of squares, but instead of saying 4z, what do I say? 4z squared and 4z squared. And then 1 and plus and minus. And that still works because what did we call these guys when we have two parentheses that are so close to being the same but different signs? There's a word. What's the word? Yes, conjugate. And so that middle one cancels out. 27. Then 29. I'm going to squeeze it over here. 15x to the fifth. Oh, they're making these big. Minus 72x cubed. Minus 108x. So I don't want y'all to look at those big uglies and think it's too hard. I want you to start with little things like, do they have anything in common? They all have an x. I'm definitely taking that out. And then 15 doesn't go into 108. 5 doesn't go into 108. or this one. But 3 does, right? 3 goes into this one because it adds up to 9, and this one also adds up to 9. So 3 comes out, that leaves 5x to the 4th. Minus 3 goes twice, 24x squared. Minus 3 goes 3d6, 36, just kidding. So, am I done? Probably not. So 3x, this is a trinomial, so 2 sets of parentheses. I'm definitely using that rule I just used, which is x squared. And there's only one choice for 5. So I always start there. 5 is only 5 and x squared. That's it. There's no other way to factor it because I'm not factoring in any sort of decimals. That would be too complicated. Then I have to think about 36, and there's a lot of possibilities there. So you could say what we did before was we multiplied them together and said 36 times 5 is 180. So we could say 180 is 180 times 1, 2 times 90, 3 times 60, 4, 25? No. 4 goes, that's stupid. 4 goes 4, 45. 5 goes 3 times 24. Do I have anything that subtracts yet? 6 goes 30. Ooh, found it. So what am I looking at? I'm looking at the factors of 5 and the factors of 36. I multiplied them together, and that gives me some possibilities. 6 and 30, those are my possibilities, which means that in order to get 6 and 30, Cadence like for me to write it all out. I can do that, or I can do where we just sort of puzzle it out. If I'm trying to get 30, what does 5 have to multiply by to make 30? 6. So 6 has to go here to make 30. Do you see it? And that leaves 30's done. That leaves 6 to be here. Do 6 and 6 make 36? Yes. So that means we need to be 30 is negative 30x squared, and this would be plus 6x squared makes negative 24x squared. I would try to factor these again because it's x squared, but is 5 a square? No. So 5's not special. It's not special. X squared is squared, and it's a minus, but is 6 special? No. 6 is not a square either, so I'm done. So this was hard because it had big numbers, but what I need you to do is do this thing that we did before, which was multiply A times C, make a list, and when you get to things that work, you can figure out how they would work in your problem. So does that help you with 29? Which part was it that got you stuck? Or is it just because it was big numbers and you're like,
I was just kind of confused by it. Yeah, I don't really know.
okay, so we definitely want to make it simpler first. So definitely take out the greatest common factor because factoring the 15 and the 108, that's hard. Okay, and then this x would totally mess us up. So you definitely have to take out the greatest common factor first. And then there are rules. Like 5, there's only that one choice. It's the 36 that made it hard because I could have done a lot of things. I could have said 1 times 36, 2 times 18. Like there's a lot of choices there. So this list made it so I could tell what my goal was. And when I had a goal, I could figure out how they worked out in my problem. And this takes practice. It just takes us doing more and more of these. Okay, so 29, after that was 33. 33 says, actually solve it now, 18s cubed minus 50s. Oops, that's not what they told us. They told us 18s cubed equals 50s. Sorry, I did a little step in my head there that you may not have thought about doing. And I'm actually okay with that, even though I want you to write down the problems. If you see one step that would make the problem one step shorter when you write it down. So 33, we can't actually solve this until we get it equal to 0. How come? And I ask how come because I might ask you that, like on a test, for you to explain in words why. How come? But what makes it so the 0 is important? Why is equal to 0 important?
So you can find S or
But what about the math? It makes it the 0. So I move the negative 50 over, then what would I do? I'm going to answer that question. I'm just going to get to it. Pull out, so at least a 2, right? 2 and an S? Okay, so 2 and an S can come out. That's my greatest common factor. That leaves 2 times 9 and an S squared minus 25. And check it. That makes 18. That makes X cubed minus, and then this makes 50S. So check it to make sure you haven't dropped anything anywhere. Hopefully you're getting good at spotting that this is a binomial, and it must be special to factor it, and it is, because we got square, 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 and a minus sign. So 2S. It's going to be 3S, 3S. 5 and 5, one's a plus and one's a minus, equals 0. What comes next? To solve it. I have 3 solutions here. You put them all equal to 0, and that's why the 0 is important. Is there something special that you can multiply any number by and get the same number? So, okay, so if I said you have 14 and you multiply by 1, you get 14. But if you had 15 and you multiply by 1, you don't get 14 again. There is one number, that's 0, that if you multiply by any number, you get the same number. It's the only number that does that, okay? So that if you multiply 14 by 0, you get 0. If you multiply 27 by 0, you get 0. If you multiply negative 27 by 0, you get 0. 0 is why it's important because of the 0 product rule. It's the only number that's special in that if you multiply any number by 0, you get 0. 0 product rule. I don't know what I was writing there. That says that if this number is 0, the whole thing is 0. If the middle number is 0, the whole thing is 0. If this last number is 0, the whole thing is 0. The purpose of setting it equal to 0 is because there's not something special that you multiply and get 4 or 7. It has to be 0. And so we say 2s equals 0. 3s plus 5 equals 0. And 3s minus 5 equals 0. And we start to get better and better at this math, and we skip this step, but I need for you to know why we do it. Because I have students who do it great in this class, and then they go on and they're in pre-calculus or they get to calculus and they want to factor something really hard like, okay, not really hard, I'll just give you a slight example, and I'm not done with this problem, but I will be. Let's say we have s squared minus 14s equals 147. And they're like, dude, I don't know how to factor 147. And so they think they can go s times s minus 14 equals 147 and solve it. S equals 147. That doesn't work, though. Cole, you okay? Okay. So it doesn't work because I can't multiply this by something and get 147 and this by the same number and get 147. It only works with 0, okay? So you have to set it equal to 0, and that's because of the 0 product rule. When we solve this, we get s equals 0. When we divide both sides by 2, 3s equals negative 5. So s equals negative 5/3. And here, 3s equals 5, so s equals positive 5/3. Set it equal to 0. But you can't do this unless you can factor. So we're trying to get really good at factoring in this section. 36. 4 w to the 4th plus 4 d w squared minus 44 equals 0. Okay, so 36 is set up and ready to go. Obviously, we've got a common factor. It's only the 4, though. We can't take out any w's. So we're going to take out a 4. And then minus 11. And it's a much simpler problem to work with. We're going to have two different signs here, right? This tells you two different signs. That means we're subtracting. What are factors of 11? There's only one set. 1 and 11. So we have w squared because it's the same as the middle one. And then we've got plus 11 minus 1. That makes 11 when you multiply and 10 when you subtract. Do any of these factor again? So always look for difference of squares. One of these is difference of squares. This one, yeah. Always. Like this is like that thing that will be the bane of your existence. It means it just drives you crazy up a wall, whatever you want to say. It's always kind of present. So the plus 11 doesn't have one, but this one's going to be w minus 1, w plus 1. Square, square, and a minus sign. So we could try to solve all of these. We can write them all down. I want you to get in the habit of saying every factor that you have, all 4 of these are factors, 4 equals 0. And then that one you just go, well, that's stupid. I'm just going to mark it out, okay? But don't drop anything until you get to the end because it might be something you need to solve. So we set each of them equal to 0. W squared plus 11 equals 0. W minus 1 equals 0. W plus 1 equals 0. These are 2 easy ones to solve, 1 and negative 1. So that one's done. How about this one? Why did they include this in our answers? That's right. So they said find the real number solutions. I don't know why they do that here because we could totally solve this. In the next section, we're supposed to solve for it. So we might as well say, well, we'll take the square root of both sides and put a plus or minus. W equals plus or minus 11 doesn't get to come out, but the negative makes an I. So we've actually found the mathematical roots for this. And we have 4 of them, which we're going to learn soon is what the magic number because this has a 4th degree. I have 1, 2 here, and 1, 2 here, and that makes 4. 2 of them won't show up on my graph. They're imaginary, but 2 of them will. We'll talk about that later. They didn't want this one, but it seems crazy to me that they would just drop it because you don't know why. You're just like trying to answer stuff, and you're like, well, what happened to this one? Well, this is what happened to that one. They just wanted the real number solutions. But you could totally answer that, and we will soon, so it's fine. 36 and then 37. We all ready? Was that too fast or are we good? Okay. 37. It says, ooh, cubes. Nope. We're still not going to have any of those cubes. Did y'all learn SOAP? Do you know it now? Some of you made up random things for your homework, and then I made you go back and look at it again. And then you had to do it on Delta Math. So we might look at SOAP again because we haven't done that live together. And then this said equals 0. 37. No, it doesn't. It says 4z the 5th equals, and I moved it over because I just do that automatically. So here's the problem I'm trying to solve. I've set it equal to 0 so I can factor it. 84 and 4 have 4 in it. 4. And z cubed. So that leaves me with z squared and a minus sign. 4 and a 4 goes twice. 21. The end equals 0. Whoa. Sorry, keeps turning. Is 21 special? I mean, if you're playing blackjack. But as far as factoring, no. So we can't factor that one again. So the rule is, after you've factored it as far as you can, you take the first factor and you set it equal to 0. You take the second factor and you set it equal to 0. It's as simple as that. Your goal with factoring is to make tiny equations that are so easy to solve. So this one's easy to solve. Divide both sides by 4. Z cubed equals 0. You could probably just guess Z has to be 0 here. So Z equals 0. You're actually taking the cube root, but we haven't really done that yet. Here, you're saying Z squared equals positive 21. On the other side, take the square root, plus or minus. Don't kill a puppy. If you forget the plus or minus, that's when you mathematically, the meme is kill the puppy. That's so sad. Z equals, the square and the square root cancel. Z equals plus or minus, does 21 simplify at all? Does it have any squares in there? It's just 3 and 7, right? So that's not, I can't do anything with that. So I just leave it the square root of 21. And I have 1, 2, 3 solutions. This one is repeated 3 times because it's cubed right here. So that means 1, 2, 3, 4, 5. I have 5 solutions. Just 3 of them are the same. 37. Okay, none of those had difference or sum of cubes. Do y'all need to see that again live, or have you memorized it yet? Because I did it again and told you to check it again. Do it some more?
Yeah.
Okay. So let's see difference in sum of cubes. Okay. So here we go. And this one you've got to memorize. And I tell students that, and then they think they've got it, but then they don't. So actually, you need to memorize this. What do you need to do?
Memorize.
You need to memorize it. Okay, so let's say we have this problem. Negative 4x to the 4th minus 500x. We'll go ahead and make it equal to 0 and solve it. So this is not new stuff. This is just us going back over small details. It's the same kind of problem we just did. What do we take out first? Definitely an x. Okay, x. 2 will leave us with 250 here. Will 2 go into 250? 4. Yeah, so let's take out 4. And I don't know about you, but do you like that first one to be negative when you factor again? I really dislike the first one being negative. I'm actually going to take out negative 4. That's just my personal preference. I like that first one to be positive. It helps me with the next factoring if I have to factor anymore. So let's see. I'm taking out the negative and the 4 and an x. That leaves x cubed. How's that? Okay? Okay. And then I took out the negative, so this is now going to be a positive. I took out this x. Now I just need to do 4 into 500. So 4 goes into 5 once, into 10 twice, and into 25 times. So I told you I was going to do difference in sum of cubes. I have that now. I have this part factored. Negative 4x is going to stay. Difference in sum of cubes is a binomial and a trinomial. What is the base for x cubed? Yeah, so it's x that's cubed. And then how about 125? What's the obvious choice? 5. Yep, definitely 5 is in it. So it has to be 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 25. 125. Okay, so 5 cubed and a plus. So you look at it and go, it's a binomial. It's special. It's definitely cubed because the first one said cubed on it. So it had to be a cubed. That means this one had to be a cubed if I'm going to factor it. And the rule goes, what? What are my signs? Yep, positive. So same. Opposite. Thank you. Sorry, I'm making a really loud for my video. So we'll leave it there. Okay, so same, opposite, same, opposite. Then what? Always positive. So that's what that means. So, always positive. Same, opposite, always positive. So, that's so easy to memorize. You definitely can memorize that. And then you just do the bases. So what goes here? X. How about here? 5. Some people will just try to put in the same as what's given, but it has to be smaller because look, when you take these and square them, so in this first position, it's going to be x squared. In the last position is 25. 5 times 25 is 125. See how that works? If you had put 125 here, then your number would be humongous, okay? You need to be able to check it and go 5 times 25 is 125. That's given. In the middle one, you're like, ugh, what was that roll? Well, it's just these two together, 5x. Okay, so it's not a hard rule to memorize. It looks like it might be hard, but you find the bases, you learn SOAP, and then you square, square, and multiply in the middle. Okay, that wasn't the rest of the problem. So the rest of the problem is, now that we've got it factored, and this does not factor again, we're going to have negative 4x equals 0. X plus 5 equals 0. X squared minus 5x plus 25 equals 0. Here, what's x? And then here?
Negative 5.
And this didn't factor. What would we have to do to do this problem? The quadratic formula. We would end up with an imaginary answer, and we're not looking for imaginary answers in this section, so we wouldn't have to actually solve that one. So we would have 2 zeros that are real we could find. Any other questions? Okay, this section's really important. So I want you to know how to factor. I want you to know how to solve because we'll use it forever, okay? Like I said, in calculus, sometimes they do crazy stuff. It's because we're still factoring. So what I want you to do for your distance learning Friday is just a couple of problems in this section that are equations to round it out, okay? So we've gone over stuff together. I have a few problems. I'll put them up for you now so you can see them. I'll post this video if you want to go back and look at it. And then I'm going to say everything's due tomorrow at 3. You can do it tonight and turn it in like regular and be done. Or you can turn it in tomorrow by 3 if you want to work on it tomorrow as your Friday stuff. But till 3 means that you don't have to get up early. You just have that time to do it as you will. Okay? So I will look up those problems and post it for you. Okay, bye.